Welcome to our channel. Please don't forget to subscribe. Thank you. Number 1. Explain the origin of the force that causes the electron to spiral in this manner. First, the electron is charged. Second, the magnetic field of a moving electron interacts with a uniform magnetic field. Second mark. Explain why the radius of the circle gradually decreases. Electrons ionizes atoms in air. Here it is. Ionization means adding or removing of electron. During ionization, the electron loses kinetic energy. So the speed decreases, of course. So as well with the radius. The formula for radius is m is equals to mv all over q times the b. So when the kinetic energy is reduced, the v is decreased. If the v is decreased, so as well with the radius. Let's go to b. bi. Speed of electron is given, the b is given, the charge of electron is QE. Now the force on electron, so let's have Vi here using the formula. This is magnetic force, QVB. Q times velocity times the b, it will give you 4 times 10 raised to minus 13 Newton. II. The radius of the path, FC, is equals to mv squared over r. Now the radius will be mv squared all over fc. Now there is no fc, but remember that fb provides fc. So your fb will be put here. Doing the calculation, it will give you around 2.278 times 10 to minus 4 meters. Let's move on. Let's go to number 2. Here. Okay, that's it, that's enough. Number 2, you have the source at the top, and this is the first source is proton. Using your FBI, remember the Federal Bureau of Investigation, you would know that your force is actually moving this way. Yes? And if your force is moving this way, it means the magnetic field is into the page. Right. So, copy the diagram and sketch the path of a proton from the source to the detector. Draw an arrow 2 points of the path. Okay, so it will move like this. Okay. All right. So draw an arrow to 2 arrows, so between points, 2 paths. Remember that F is always 90 degrees with a V, so here could be there also. State the direction of the magnetic field. Answer into the page. So this is the drawing. This is the drawing here with a cross symbol into the page. Next. Let's go to letter B. For letter B, the speed of proton as it enters is this one is your speed. The magnetic density is this one. So calculate the magnetic force. So what is the magnetic force? We know the formula for the magnetic force. F is equals to Q. F is equals to Q times the V times the B. So using that formula, you can get 1.6 times 10 raised to minus 13 Newton. The radius of the curvature is again, will be given by Fc is equals to mv squared over r. Sorry, mv squared over r. Now, your Fc is actually the magnitude of Fb, so don't worry about it because Fb gives Fc. So using your formula, your r will be around 0.167 meters. Let's go to C. 2 changes to the magnetic field in the area are shown me. These changes allow the electron with the same speed to be, as the proton, to be deflected along the same path of the proton. So it means to say that you change from proton here, you need electron. And you want the force to remain in that direction. So it means to say we need to reverse the direction of the B. That's one. So one of the changes here is reverse the direction. Reverse the direction of magnetic field strength from where? From this to into the page. From into the page to out of the page. Next is that 2 changes should be made to the radius. We know that R is equals to mv all over q times the b. Now we also know that the mass of electron is smaller compared to the mass of proton, right? So to the mass of the proton here. So it means to say that since it is electron now, the R will reduce. But we need to have the same R so that the electron can follow the same path like the proton. So what we should do is that we need to reduce the B. If we reduce the B, it will increase the R. It will compensate the loss of the R. So we are going, the next change is to reduce the magnetic field strength of B. Because we are losing in terms of mass, that will be compensated by reducing the B. If you reduce the B, it will increase the R. Thank you. Let's go to number 3. Number 3. I will explain. Explain why the beam curves upward and it is electron. So the electron is in this particular electric field, so the electron is here. All right. First answer, electron is charged and is in the electric field. Second answer, electric field down, so there is a constant force upwards. Number 2, explain how the pattern formed on the fluorescent screen shows that all electrons have the same speed as they leave. So here, answer number 1, single spot found on the screen. So since it is only in one spot, it means they have the same speed. Number 2, you're going to make your argument higher. Higher speed electron would be deflected less, and hence spot would be larger. What does it mean? If the V is big, it is deflected less like here. So your deflection is only this one. A while ago is this one. So if they are not moving in the same velocity, then the higher could be here. That makes your argument stronger. Let's go to B. Write down the equation relating the speed V. Relating the speed V. So it means to say here the electron, the potential difference is doing work on the electron. So the electron moves. So let's go to B. So work is done and on the electron QV. And work is simply the kinetic energy. That is mv squared all over 2 equals Q times the V. That is the relationship. The V is already found. Let's go to C. So the C, you have the purpose to cancel. So we know that the Fe is going up. Okay? It means to say your magnetic force should go down in order to cancel. Yeah? State the direction of the magnetic field. It should be into the page so that the force is going down into the page. Using your FBI, okay? Take note it is electron, so the current is flowing in the opposite direction. If you want to use your Federal Bureau of Investigation, Fleming's left-hand rule, it's into the page. Next is that write down the equation relating the speed of the electrons V that exists between the plate and the magnetic flux density needed to make the electrons pass undeflected. Undeflected means the two forces are equal. So the magnetic force balance with the electric force. Okay, so Q times the V times the magnetic field strength times the Q times the E. There you go. Then the velocity, you can eliminate Q is equal to electric field all over the magnetic field. That's it. Let's go to the third one. I think I need a bigger space for the third one. The third one is that calculate the value of the B. So this is the B that we're looking for. So here the B, the formula will be electric field all over the B. But first let's see what are the given in this problem. So the given is electric or charge to mass ratio 1.76 times 10 to 11. What else? We have the voltage also. The voltage is 500. We have the radius or the distance between the plate is 0.05. And therefore we can calculate the electric field. Electric field is simply the voltage all over the distance. Then it will give us 1 times 10 to the 4th power. So electric field is calculated. Now what about the velocity? Electric field is calculated. Sorry, I think it is wrong. This equation is wrong. Right. So the electric field, we are going to calculate electric field. Not electric field, magnetic field. Sorry. Magnetic field. This is all over velocity. So now our problem is the velocity. How to calculate velocity? We can use this particular equation here. This one. Right? So if we use our velocity formula here, the velocity will be the square root of twice the voltage multiplied by the electron charge Q. Q or E is the same all over the mass. Now, E over M is given. It's this particular value. Without calculation, you can have your V. And your V is around 1.88 times 10 raised to the 7th power. We are moving fast because we want the recorded video to be very short. Now, so you have your velocity and your electric field. You can calculate your B. Now your B is around 5.3 times 10 raised to minus 4. Let's move on. Let's go to number 4. This is the second to the last question. Number 4. In number 4, I will write the given immediately. You have here the B. The B is equal to 6 times 10 to the minus 5. That's right. And the velocity is 1 times 10 to the 6th power. Now the mass of the proton, we know it's 1.67 times 10 to the minus 27. Okay. Now the charge of the proton, we know also the charge of the proton is positive 1.6 times 10 to the minus 19. The mass of helium is given here, and the charge of the helium is also given here. Now the first question is calculate the radius of the path of the proton. So path of the proton, we know the formula. R from the P bar, I give you the code, P bar. Huh? Momentum is mv, that's P, equals BER. That's why it's P bar. Now, my radius will be what? My radius will be m times the v. This is mass of the proton. Okay, they have the same velocity. Okay, and they are entering also at the same amount of magnetic field strength. So, doing this calculation, because the values are given, the charge is given, the B is given also at the top, then we can have the radius of the proton, R of the proton. So R of the proton is around 174 meters. We can round this off to 170 meters for easy viewing. Okay, this is your radius of the proton. Second one is that do the diagram to show the deflection caused by the magnetic field on a proton and on a helium nucleus, which both have the same initial velocity and magnetic field. State the diagram radius path by each particle. So it means we need to calculate the radius of the helium gas. Okay. The mass of the helium gas here is 6.8, and the other one is 1.67. So this is 4 times as big as this. So radius of the helium is equal to, we can have the radius of the proton. We can see it's, because they have the same velocity and magnetic field, then we can simply take the ratio. So the ratio is the mass of helium all over the mass of the proton, yeah, all over the charge of helium all over the charge of proton. That's it. So is equal to R times the P. We know the ratio. This is 6.8 divided by 1.67 is around 4. And the charge of helium is actually 2, because helium gas is this one, 2 and 4. So the charge is 2, and then the charge of proton is 1. So divided by 1 is simply 1. Yes, simply 2. So 4 divided by 2 is equal to 2. So the answer is twice the radius of the proton. So it means to say that the radius of helium, if we put it twice here, it will give us around 346. Actually, we can write it to 215 meters. Then we draw. The answer is draw. So we can draw like this. This is your R proton, and the other one is big. You double then this is the R of the helium. Let's move to the next, number 5. Last number 5. Have patience. Draw the diagram of the apparatus to explain why the oil drop remains stationary. Okay. So draw the diagram and explain why the oil drop remains stationary. Okay. You have letter A. You have a parallel plate, electric field uniform. This is positively charged at the top and negatively charged. You connect it to a battery here. 1, 2 small. Make sure that the terminals are correct. So the electron is here, and it says there it's stationary. It means, so you're going to explain that the electric force is going up and balanced with the weight of the oil drop. Okay, so this is actually oil drop here. That's it. You get 3 marks from this. Let's go to B. In letter B, Calculate the charge on the oil drop. So we can calculate the charge because Fe balanced with the weight, which is actually mg. So Fe is Q times electric field now is equal to m times the mg. So the charge will be mgd, okay, or the weight of the all over the electric field. We can solve the electric field, okay, because the electric field is given. So what is electric field? V times d all over the voltage. Let me check. Charge QA is equals to weight, and then Q will be weight times the distance all over the V. This is voltage, okay, because electric field is equals to voltage all over the distance. So I hope I am not confused of the equation here. Otherwise, please do make some corrections because I'm making it very fast. So the Q now is 3.2 times into negative 19 coulombs. This is just equal to 2 electrons. Yeah, because one electron is 1.6, so double it, it's 3.2. It's 2 electrons. Now let's go to the letter BII. Explain what is meant by quantization. So I'll explain. First answer, because you need 2 marks here. Charges or charge exist in multiples. The smallest multiple of charge is the charge of electron. That's it. That is quantization of charge. Let's go to C. CI. Describe how the charge on the oil drop can be changed while the drop remains between the plates. Answer. A source of beta radiation ionizes the air so that the oil drop can either pick up or remove charge. CII. Let's go to the CII. Explain why only certain values of PD are found in this experiment and predict another value of PD that may be required when the charge of the oil is dropped. Okay, so from this equation here, we can say that the voltage is actually mgd all over Q. Okay, how to explain that one? Since the Q exists in a specific value, it means that the voltage also exists in a specific value. That's the argument you can make. So we are finished. That's all. Thank you, and please don't forget to subscribe our channel for more updates.